Hello everybody, welcome back to Mr. Morrow's Algebra class. Today we're going to be talking about 1-4 Part 1, solving one-step and two-step equations. This is absolutely the most quintessential part of algebra. If you can learn how to solve equations, then the rest of the year is very doable, a lot easier to handle. So let's go ahead and learn how to solve these one and two-step equations. The first thing we're going to start with is solving one-step equations. Now, the goal for any equation, one-step, two-step, multi-step, it's the same. It's for you to isolate the variable. That means get the variable all by itself. Isolate the variable. If you're solving for y, you want to get the y all by itself. So in other words, you want to solve for x over 1, or basically the variable over 1. You want the x in the numerator, never in the denominator, okay? You want to solve for x in the numerator. You don't want to solve for 1 over x, or you don't want to solve for 2x, or you don't want to solve for negative 3x. No. All of that is no good. You always want to solve for x over 1, or the variable over 1. Okay, you want to have the variable in the numerator. Now, solve single-step equations is very simple. All it takes is 1, undo addition with subtraction. Pretty simple. 2, you can undo subtraction with addition. You undo multiplication with division, and you undo division with multiplication. It is literally that easy. So let's go ahead and let's practice. I've got 27 plus n equals 46. So whenever I have a one-step or two-step equation, I always ask myself the same question. How do I get the variable alone? So the way I figure that out is I say to myself, okay, 27 plus n is 46. So what is the relationship between 27 and n? The relationship between 27 and n is that they are being added. So to undo addition, we subtract. So negative 27 to both sides. Those cancel. N equals 19. Number 2. What is the relationship between the q and the 13? They're being added. I undo addition with subtraction. So I'm going to subtract 13 to both sides. And that's going to be negative 9 equals q. Now, if you've noticed, I subtracted 27 to both sides. I subtracted 13 to both sides. Whatever you do to one side must be done to the other side. It's kind of like a scale, okay? It's kind of like a scale. If I have a scale here, all right, and I put 10 pounds here, and I put 10 pounds here, we're even, okay? But if I take away 10 pounds from this side, if I take away 2 pounds, let's say I've got 8 pounds now. What do I have to do to this side to be equal to this? Well, I've got to subtract 2 pounds as well. Okay? So then I would have 8 pounds equals 8 pounds again. So whatever you do to one side of the equation, you must do to the other side of the equation. It keeps it balanced, like a scale. All right, let's continue. J minus 3 equals negative 7. So I'm going to undo subtraction with addition. So J equals negative 4. Same thing here. P plus 7.1. I want to get the P alone, so I'm going to subtract 7.1 to both sides. That's going to give me negative 9.6 equals P. Y minus 19 equals 37. Okay, I'm going to undo this subtraction because y minus 19, so the 19 is being subtracted from y. I'm going to undo subtraction with addition. Whatever I do to one side, I do to the other side, and that's going to be 56. Now let's work with multiplication and division, undoing those single-step equations. I got negative 7y equals 28, so I'm going to divide by negative 7 to both sides. Why did I do that? Well, sorry I jumped the gun there. What is the relationship between negative 7 and y? They're being multiplied. How do you cancel out multiplication? With division. So y equals negative 4. Negative 96 equals 4x. What is the relationship between 4 and x? They're being multiplied. How do you cancel multiplication? You divide. So you're going to divide 4 again to both sides. Because whatever you do to one side, you must do to the other side. So negative 96 divided by 4 is going to be x equals negative 24. Now, m divided by 7 equals 12. This fraction bar represents division. So the m and the 7 are being divided in this particular case, all right? They're being divided. So how do I cancel out division? By multiplication. So really what I have here is a 1/7 times m equals 12. So to get rid of this 7 down here in the denominator, I'm going to simply multiply both sides by its reciprocal. So I'm going to multiply by 7 over 1. These 7's cancel, and I've got m equals 84. So to get rid of a denominator, or a fraction for that matter, just go ahead and multiply by the reciprocal. For example, here I've got k over 4 equals negative 17 over 2. Let me move this guy over here to have a little bit more space. All right, so I've got k over 4. I want to get rid of that 4 in the denominator, so I'm going to multiply 4 to both sides. I'm going to multiply by the reciprocal of 1/4, so I'm going to multiply by 4 over 1. It's very important that you have it over 1, guys, because that way you won't multiply it to the denominator accidentally. And then here I can cross reduce, so that's going to be negative 34. Okay, negative 34. 2x equals negative 24. Well, how do I get rid of multiplication? I get rid of multiplication by division. So x equals negative 12. Okay, let's practice some more with fractions, because I know that fractions sometimes are tough for everybody. Well, I've got 2/3 x this time equals 18. 2/3 x this time equals 18. I'm just going to move it over to have a little bit more space. Well, I want to get rid of this 2/3 that is being multiplied to the x. So how do I get rid of a fraction that's being multiplied to a variable? I just simply multiply it by its reciprocal to both sides. So the 3's cancels, the 2 cancels, x equals, let's cross divide, and that's going to be 27. For number 2, I'm going to get rid of this 3/4 that is being multiplied to the x by multiplying by the reciprocal of 4/3. Those cancel. X equals, remember this is 9 over 1, so let's cross reduce, and that will be 12. 2/5 x equals 4/7. I want to get rid of this 2/5 that is being multiplied to the x, so I'm going to simply multiply by its reciprocal. Those cancel out. X equals, cross reduce, 10/7. Okay, now what about when I get a mixed number? Well, when you get a mixed number, let's remember back from middle school, you cannot multiply and divide mixed numbers. You have to first turn them into an improper fraction. So this is first going to become 2 times 3 is 6 plus 2 is 8/3 x equals 12/15. Now, I want to get rid of the 8/3 that is being multiplied to x, so I am simply going to multiply by the reciprocal of 3/8. Those cancel. X equals, 4 goes into 8 2 times, 4 goes into 12 3 times, 3 goes into 3 1 time, 3 goes into 15 5 times, so I have 3/10 as my answer. Okay, 2/7 equals 1/3 plus a. Well, there's several ways to do this. You could go ahead and subtract 1/3 to both sides, okay? And then you'll have 2/7 minus 1/3. This goes to 21, that goes to 6. This goes to 21, that goes to 7, and that would equal negative 1/21. Okay, so you would have negative 1/21 equals A. Now, some people like doing that. Some people work with fractions very well. Some people do not. So for those people who do not, I've got another way for you. If you don't want to work with fractions, get rid of the denominator. How do you get rid of the denominator? By simply multiplying both sides by the least common denominator. In this particular case, the least common denominator between 7 and 3 is 21. So I'm going to multiply 21 to both sides. So 21 times 2 is 42, divided by 7 is 6. Here I have to use a distributive property. 21 divided by 3 is 7, plus 21a. Subtract the 7 to both sides. So that's going to give me negative 1 equals 21a. 21 times a, they're being multiplied. So how do we cancel multiplication? With division, divide by 21. A equals negative 1 over 21. So either way works for me. For number 6, this is pretty easy. You get rid of a negative 4 2/3 by adding 4 2/3. Unlike multiplying and dividing, you can add and subtract mixed numbers. You do not have to turn them into improper fractions. And this is going to become 6 4/3. Now, let's look at this over here. This 4/3, 3 goes into 4 one whole time. So you have to add that whole value to the 6. So it's going to be 7 1/3 is your answer. Don't let decimals stress you out. Decimals are not scary. Negative 5.3 plus y equals 8.9. The negative 5.3 is being added to y. How do I get rid of a negative 5.3? By adding 5.3 to both sides. So y is going to equal 14.2. Last but not least, h plus 2.8 equals negative 3.7. I'm going to get rid of a positive 2.8 by subtracting 2.8 to both sides. H equals negative 6.5. Hope that makes sense for single-step equations. Now, solving two-step equations. The goal is exactly the same. It's going to be the same for every type of equation we ever solve for. Isolate the variable. Get the variable all by itself. You want to solve for x over 1. You want to solve for the variable in the numerator. Now, for two-step equations, it's very simple. 2 steps to two-step equations. Sorry about that. Step 1. You're going to undo addition and or subtraction first. Step 2. You undo multiplication and or division second. And that's literally it. Let's practice. Okay, I've got 3n minus 4 equals 11. I want to get the n all by itself. So since this is a two-step equation, because I have two different operations going on, I'm going to have to first get rid of addition and or subtraction. So I'm going to get rid of this negative 4. How am I going to get rid of that negative 4? By adding 4 to both sides. Now I have 3n equals 15, which is now a single-step equation. 3 times n, undo multiplication with division, divide 3 to both sides, n equals 5. Number 2, I want to get rid of the positive 2 first because I want to undo addition and subtraction first. So I'm going to subtract 2 to both sides. Y over 5 equals negative 10. Y divided by 5. Remember, to get rid of a denominator or a fraction, simply multiply by the reciprocal. So I'm going to multiply by 5 over 1 to both sides, and y equals negative 50. For number 3, I want to get rid of this negative 5 first, because I want to undo addition and subtraction first. So I add 5 to both sides. Negative 9 equals 3c. Divide to cancel out multiplication. C equals negative 3. Now, remember what I told you about the fractions. We could add 1/3 and then divide by 2 by multiply by the reciprocal 5/2, but that's going to be very inefficient. So why don't we go ahead and do this? Let's multiply by the least common denominator of 30. 30 times 2 is 60, divided by 5 is 12x. 30 times 1 is 30, divided by 3 is 10. 30 times 3 is 90, divided by 10 is 9. Add 10 to both sides to get rid of that negative 10. 12x equals 19, divided by 12. X equals 1 and 7/12. Okay. Now, when you have this case, like in number 5, remember what I said, to get rid of a denominator or a fraction, simply multiply by the reciprocal. So let me move this over. So the denominator here is 2. So I'm going to multiply both sides by 2 over 1, the reciprocal of 1 over 2. So I'll multiply by 2 over 1. That cancels. I've got y minus 4 equals 20. Add the 4. Y equals 24. X plus 3 over 5. You're going to multiply both sides by the reciprocal of 1/5, which is 5 over 1. The 5's cancel. X plus 3 equals negative 5. Subtract 3 to both sides. X equals negative 8. For number 7, I'm going to multiply by the reciprocal of this is the 7 in the denominator. So the reciprocal of 1 over 7 is 7 over 1, which is what I'm going to multiply both sides by. So it's going to be negative 14 equals d minus 7. Add the 7. D equals negative 7. And last but not least, for this particular case, it's just a regular two-step equation. I'm going to undo addition subtraction first. So I'm going to subtract 4 to both sides. The 4's cancel here. I've got negative 5 equals 5/8 x. How do I get rid of that fraction or a denominator that's being multiplied to a variable? I'm going to multiply both sides by its reciprocal. So I'm going to multiply both sides by 8 over 5. Remember, this negative 5 has a denominator of 1. This cross reduces, and that turns into a negative 1. Negative 1 times 8 is 8. This 8 and that 8 cancel, that 5 and that 5 cancel. So I've got negative 8 equals x. And now you know how to solve for both single-step and two-step equations. Thank you so very much. Have a great day. God bless. Bye-bye.